Good morning, ladies and gentlemen. This is Mr. Rowe. We're taking a look at geometry, part A. This is lesson 9, and we're going to look at how to prove that triangles are congruent. And we're going to use a flow proof. So this will be a change from our standard 2-column proof. So let's take a look at what we're doing. We got proven triangles are congruent. Remember, in the lesson, we had some postulates and theorems that we talked about. The first one was side, side, side. So that's basically just showing that every side of one triangle is congruent to every side of another. We had side, angle, side. So if we can show that two sides and the angle that is in between those two sides is congruent to the same two sides and the angle of another triangle, that they're congruent. Then we had angle, side, angle, which is kind of similar to side, angle, side, except it's two angles, and then the side that is in between those angles is congruent to the same two angles inside of another. And then we have angle, angle, side. So that's two consecutive angles and then a side that's not included in those two angles. So it's two angles and then another side off of those angles is congruent to the same two angles inside of another. So let's take a look at our first example. Well, let's look at what our flow proof is first. So a flow proof uses a flow chart to make statements and reasons. Now, we've been using 2-column proofs with a set of, with a column for the statements and a column for the reasons. So basically what we're doing is we're putting the statement and the reason together in a flow proof. So we'll have a statement and a reason right underneath. We might have another statement with another reason out to the side. And then once we get some initial statements, we'll be able to connect to some other boxes in a logical order in order to get down to the final conclusion. So this first statement, there might be something that we can say based on this statement in the next statement. And we might also have from this one. So we'll have a statement based on this statement. And we'll have a reason based on that. Same thing for this one. And then sometimes and typically there is another statement that's based solely on the diagram that we're given, reflex properties, vertical angle properties, those kind of things that we will look at in the lesson. And then we'll have a reason for that. And then we'll have our conclusion with a reason, and all of these will point right to it. So this will be the reason that this is true. So let's take a look at our first example. So our first example, here are our two triangles. And let's see what we're given. We're told that BD bisects AC. We're also told that AB is congruent to CB. And we're going to prove that triangle ABD is congruent to triangle CBD. So taking a look at what we're told, we can, and it's always a good idea to come up with a plan before you actually start the proof. The plan will help you figure out what theorem you're going to use or postulate you're going to use at the end to make your final conclusion. So BD bisects AC. So this is an important statement because this bisects AC. So what that tells me right away is that these two sides are congruent. So I've already got two sides, or one side of one and another congruent just based on the given. And I'm also told that AB, so this segment, is congruent to CB. So I know that. So I've got two segments. I don't know anything else, but based on the diagram, you see this segment BD, it's a member of both triangles. So we have a property of congruence called the reflexive property. The reflexive property tells me that that side is going to also be congruent to itself. So I've got three sides congruent to three sides of another, so I'm going to end up using side, side, side. So BD bisects AC would be my first statement. And how do I know that? It's a given statement. That's going to tell me that AD is congruent, or AD equals CD. We're not congruent yet. We just know that they're equal. How do we know that they're equal? That's the definition of a segment bisector. A segment bisector cuts a segment into equal parts. So once we know that they're equal to each other, then we know that those segments are congruent. And that's by the definition of congruent segments. Now, what else do we know? So we've got one set of sides congruent. So we know that. So our next thing is that we were given that AB was congruent to CB. So that's a given statement. And then what was the third set, or the third side? Well, we're using reflexive property. We said reflexive property tells me that BD is congruent to itself. And so based on all that, I can use side, side, side to show that the triangles are congruent. And all of these point right to that statement. We've got three sides, side, 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 right there, side, side, side. So that's how you do a flow proof. Let's take a look at our next example. So here are our given triangles. What are we given this time? We're told that point C is the midpoint of AE and BD. That's a lot of information right there. Let's see what else we know. Nothing. So we're going to have to prove the triangle ACB is congruent to triangle ECD. So again, I always like to start off by marking what I know, and hopefully that'll help me figure out what postulate or theorem that I'm going to be able to use. So C is a midpoint. So this is a midpoint of both of these segments. So what does that help me do? That helps me prove that AC will be congruent to CE or EC. And since it's a midpoint of both segments, then I can also figure out that BC, right here, will be congruent to DC. So I know those right away. Well, I'm not told anything else, so what I have to do is I have to use the diagram to help me. Well, I've got a set of intersecting lines right here. These are intersecting lines. Based on that, we had a rule and a definition earlier in the course about segments across from the vertex of intersecting lines, vertical angles. So here is an angle that will be congruent to another angle. So it looks like I'm using side to show that these triangles are congruent. Let's take a look at the proof. We got point C as a midpoint of AE and BD. So again, from that, that's the given. I know that AC equals EC. And how do I know that? That's the definition of a midpoint. From that same initial statement, so from this same statement, I can make another statement because I know that BC is equal to DC. So again, definition of a midpoint. Now, based on this, I now know that those segments are congruent. Now, how do I know that? That's the definition of congruent segments. We saw that in the last proof. I can make the same statement for BC equals DC. And then what else did I know? I figured out that these two angles were congruent because they're vertical angles. So I've got ACB is congruent to ECD, and that's by vertical angles are congruent. And all three of these will point to my final conclusion because I have a side, an angle, and a side. So these triangles are congruent. ACB is congruent to ECD because of side, angle, side. So that's how you do a flow proof chart or flow chart proof. So let's take a look at example 3. So here's our picture for example 3. And what do we know? We know that PQ is parallel to TS. We also know that PQ is congruent to TS. So I know two things here. Let's see what else. Nothing. So we have to prove the triangle PQR is congruent to STR. So let's see what we can know just by knowing that these are parallel and that these are congruent. So based on this being congruent, I'm going to start with this one. I know that PQ right here is congruent to TS. And now I have this parallel right here. So we had a whole lesson about parallel lines and transversals. So these are transversals. And these are parallel lines. So I know that these are parallel lines. Let me see if I can mark that. It's going to be a little bit harder to mark. So I'm just going to use this symbol to mark it as parallel. Based on the fact that these are parallel, and what I know is that this angle right here is congruent to this angle. And I also can determine, by the same reason, that these two angles are parallel. So it looks like I'm going to use angle, side, angle to show that these are congruent. Angle, side, angle. I'm sorry about that mark right there. That's an angle mark. So I'm going to use angle, side, angle here. So let's look at the proof. So because PQ is parallel to TS, what do I know? And that's a given statement. I know that angle PQR, so angle PQR, this is the first one I marked, PQR, is congruent to STR, and that is by alternate interior angle theorem. That tells me that alternate interior angles are congruent. Okay, from that same statement, that same initial statement, I also know that other angle, QPR, is congruent to angle TSR, and that's by the same reason. Alternate interior angle theorem. Alternate interior angles are congruent. So I've got two angles already. What else did I know? Well, I was given that PQ was congruent to TS. So I've got angle, side, angle. And so now I have my final proof, or my final conclusion, that triangle PQR is congruent to triangle STR. And why is that? Angle, side, angle. And here is our final proof. So here are our triangles. Now, these are overlapping triangles. Sometimes overlapping triangles are a little more difficult to determine. So that's why I like to do the plan out first. This is kind of just a mental talk through the proof before you actually write the proof. Let's see what we're given here. We're told that angle angle E is congruent to angle A. And then we're told that angle ABD is congruent to angle EDB. And then we're going to have to prove that triangle ABD is congruent to triangle EDB. So let's take a look at these markings here and see what we can do here. So we know that A is congruent to E. So angle A right here is congruent to angle E. So that's given information. Now we're also told that ADB, so ABD right here, ABD, so that's this angle, and so I'm going to mark across both, is congruent to angle EDB, so this angle. So those two angles are congruent. Well, what else do I have here? Well, I'm not given anything else. But again, this segment right here, BD is shared by both triangles. So because it's shared by both triangles, it is a congruent segment that you can use. So we end up having angle, side to show that these are congruent. And this one's kind of a short proof. So we know that A is congruent to E. That's a piece of given information. We know that ABD is congruent to EDB. Again, a piece of given information. And then BD is congruent to itself. That's reflexive property of congruence. So look at that. We've got angle, side, angle already. So this proof is done. So all these just point straight to the conclusion, which is that ABD is congruent to EDB, and that is by angle, side. So I hope this helps you develop some flow proofs for the lesson. If you have trouble making your flow proof or you still need a little bit of help with the concept, please let us know in a teacher message or make an appointment for a help session.